I have a solution that contains some iodate ions. Iodate ions react with bisulfite ions in some fairly complicated chemistry. Iodate and bisulfite react to form the iodide ion, but the iodide ion reacts with one of the materials that was a reactant. It reacts with iodate to produce iodine. Iodine that is produced by this reaction reacts with the other one of the starting materials to go back to form the I-, iodide ion. So the chemistry is sort of interwoven here. If we look at what's really happening, we have three reactions happening at once. Bisulfite and iodate are making iodide. That iodide that's produced reacts with the iodate to make iodine. But the iodine that is produced is being consumed by reacting with the bisulfite, turning it back. So we are making iodine, but we're eating it up as fast as we're making it, if I mix these materials together. Iodine is a material that reacts with starch to form a blue complex. It forms a blue color. So I can monitor this reaction, or these reactions, by adding a little bit of starch, and then when this reaction finishes, when I have no more bisulfite ion in my system to consume the iodine that is produced by this reaction will react with starch and it'll turn blue. So I will see a blue color when this reaction is done. All right, so here I have some of my iodate solution. Now, let's get my projections up here. Let's see, and maybe we'll even go here as well. Hopefully we can see what's going on. Hey, there we go. All right. So, I've got my iodate ions in solution. I'm going to add some bisulfite ions to them. And when we see the blue color, we know that we have finished with the reaction of the bisulfite. The bisulfite reaction has finished. So if I dump this in quickly, 3, 4, 5, 6, 7, 8, 9, 10. That's what's called a clock reaction. As soon as the first reaction that's consuming iodide is used up, we start to produce iodine in solution. It reacts with starch, and it gives me a blue color. So I can time that reaction very easily. It takes about 10 seconds with the concentrations that I've put together here. 10 seconds, and I get my color change. That's the completion of the reaction. Now, I have to dispose of this material, so we really shouldn't throw the iodine down the drain. We need to neutralize it. If I add a little sodium thiosulfate reacts with iodine, I2, to convert it back to iodide. So in other words, we're eating up the material that is forming the blue complex. So adding my thiosulfate, I get rid of the blue color. There's our clock reaction. And it took about 10 seconds. Let's do this again. Now I have the same concentration solutions, but they've been in ice water. So these are now cooler than the original ones. I've lowered the temperature. We're going to do the same reaction. I've got my iodate. I'm going to add my bisulfite. And we're going to time it and see what happens. So if I add my bisulfite, 3, 4, 5, 6, 7, 8, 9, 10. There's my 10 seconds. And there we go. Obviously, it took longer. It took longer with the lower temperature than with the higher temperature. So the reaction must have been proceeding more slowly. We had the same amounts of material, but it took longer for the reaction to run at the lower temperature. The rate constant for the reactions is lowered at the lower temperature. So that's how we can illustrate the rate of a reaction with a clock reaction and changing the temperature.